Hello and welcome. I'm an old guy and I do maths, and this is what we're doing today: perpendicular lines. These are lines that intersect at right angles, as you can see drawn here. We have line B, which intersects line A at a right angle. And what we're interested in is we're interested in gradient when it comes to dealing with perpendicular lines. So if line A has a gradient of 2, m equals 2, and if you're confused by the notation of m, welcome to the club. I don't know why gradient is called m, but it is, and I keep saying that I'm confused by this. If you want to look further into gradient, I have videos about gradient and line graphs and so forth on my channel. Just look them out. Anyway, we'll say that the gradient of line A is 2. Therefore, if line B is perpendicular to it at 90 degrees to it, its gradient is negative, very important, 1 over 2. So the rule for the gradient of perpendicular lines as written is as follows. The original gradient, in this case line A, when we are seeking a line perpendicular to it, the perpendicular line will have a gradient of negative 1 over m. Let's put this into practice. Let's see what we get. So I've got two fairly straightforward, simple linear equations here. These linear equations have a y-intercept rather at 0, which is why they're written as they are. There's no c value here. Again, if that raises a problem for you, go and have a look at my video on linear equations and all will be explained. Okay, so if we go through the process of creating a table of values for these two lines, the first table of values, y equals 2x. If we start at negative 2, the y value is negative 4, 2 times negative 2. Negative 1, 2, 0, 0, which means, of course, that it passes through the origin here, which is why there is no value of c here. 1, 2, 2, 4. And it's a positive gradient that runs from bottom left to top right. Over here, we have a line that is perpendicular to it and passes through the origin, 0, 0. Again, there is no value of c here. Right, so running through the values that you would get so that you could graph these on quad paper if you wanted to, or on a Cartesian plane. Negative 2 becomes 1, negative 1 becomes a half, 0, 0, that point there. 1, negative a half, 2, negative 1. And this graph has a negative gradient of a half, negative a half, negative 1 over the gradient of this line, which means that if we could map these one onto the other, this graph here would look like that, overlaying this graph, and that angle in there would be 90 degrees. Now, here's what it looks like with a few points plotted. Okay, so this is the line y equals 2x through here, and this is the line y equals negative 1 over 2x. And these are points that were worked out in the previous tables. You can go back and you can check that. So we pop this on a Cartesian plane, and this is what we get. We get this line passing through the origin here, perpendicular to this line here. Now, let's go through some equations and just work out what the gradient of a line perpendicular to these lines would be. you'll see that I do have y-intercepts here. I have c values. Now, a perpendicular line, if I just bring this back down, a perpendicular line could look like that. It could look like that. It could look like that. This line is perpendicular to that. It does not have to pass through the origin. This was merely for the purposes of demonstration, as they say. So, let's just work out the gradient of lines perpendicular to the lines that we would get from these equations. And that's pretty simple. Let's start with the first one. So y equals 3x plus 7. Y equals negative 1 over 3x. And we don't know where this line will fall, so we'll just say plus c. Y equals 2 over 3x minus 1. Y equals negative 3 over 2x plus c. Where we've got a fraction, what we do is we simply flip the fraction and change the sign. Y equals negative 2x plus 1. Y equals a half x, which is negative 2. And this would normally be negative, but we started off with something negative, so this winds up as positive x plus c. And this last one, a negative fraction, y equals negative 5 over 2x minus a half. Y equals 5. No, got it wrong. Everybody makes mistakes. You can expect to do this yourself. Y equals 2 over 5. We reverse the fraction. We make it positive. Apologies for that. Plus c. So some of you might be interested in what follows on from just simply finding the equation of a perpendicular line. Here we've got perpendicular lines and simultaneous equations. Now, simultaneous equations will be covered separately. You'll see on my playlists that there's a playlist of simultaneous equations, both for linear and for nonlinear equations, for those of you who are more advanced. I just thought I'd include this, and if it's not of interest, please just ignore it. So, perpendicular lines and simultaneous equations. What we have here is we have two lines that are perpendicular to each other. Now, how do we know that? Look at that and look at that. 2 becomes negative 1 over 2. These lines are perpendicular to each other. And again, I stress this, if you haven't looked at simultaneous equations, this is going to look a little strange. If you want to learn about simultaneous equations, I have some videos. Okay, so what we're going to do is we're going to use substitution in this case. Those of you who know what that is, fine. Those of you who don't, basically what we're going to do is we're going to take this part of this equation and this part of this equation, and we're going to make them equal each other. And then we're going to set about bringing the like terms together. So 2x and negative 1/2 x come together, and because we have moved this from here, we change the sign. And this 5 we move over to here, and because we have moved it from here, we change the sign. You could say we subtract 5 from each side, and you could say that we add a 1/2 x to each side. Anyway, what we wind up with is 2.5 x equals negative 1. Now, that's difficult to deal with. But if we then convert 2.5x to 5 over 2x, so we convert what's a mixed numeral to an improper fraction, and if that's a problem, have a look at my video on fractions. My videos on fractions. Fractions scare people, and they don't have to. Once you get used to them, you'll find they're easier to work with than decimals. Anyway, we have 5 over 2x equals negative 1. So x is equal to negative 1 times 2 over 5. Yeah. What's happened here? Well, because we moved this fraction in total from one side of the equation to the other, we flip it. Okay. So that means that x is equal to negative 1 times 2 over 5, or negative 2 over 5. And then, again, for those of you in the know, what we do with this is we put it back into one of these equations. Doesn't matter which one. Looks like this one will be the easier of the two to do it. And when we put this into this equation, what we get is the following. Here's our original equation, y equals 2x plus 5. We sub in negative 2.5, so that is y equals 2 times negative 2. Sorry, that's not 2.5. That is negative 2 over 5. Oh dear, age is catching up. 2 times negative 2 over 5 plus 5. That is what y is equal to when we sub that into this equation for x. And with a little bit of work, what we discover is that y is equal to negative 4 over 5 plus 5. Tidy that up, and we get 4 1/5, or 21 over 5, or 4.2, whichever one you want. And what that tells us is that the point of intersection of these two perpendicular lines is at this point.